So our focus today will be on Fiji, which can be downloaded for free in ImageJ.net here. And you can use different operating systems for that. Or you can download Fiji in Fiji.sci, which is a batteries included distribution of ImageJ. And you can download the version that is appropriate to whatever computer you have. Okay, so we'll start with the main interface of Fiji. It is quite simple. It contains the main menu commands, and under each would be a range of different commands as well. You have a toolbar, a status bar here, and you have a search bar. So if there is any plugin or any command that you don't remember where it's located, you just need to type it in here and it will search for it. Now, all the components of Fiji, such as macros, scripts, plugins, and the core components or libraries needed by the plugins, can be automatically updated every time you open Fiji. So when you open Fiji, you would have a message like this. So of course, it is always recommended to have an up-to-date version of Fiji and ImageJ because the Fiji team is constantly developing updates. So you'd always want to click on OK, right? Once you click on OK, you're going to see this window. It's the ImageJ updater. There are times when there are already stuff here in this box, so all you need to do is click on Apply Changes, and then restart ImageJ to apply all of these. You can, just go to the Help menu and update Fiji manually here. So go to Help, Update, and you're going to see the same window that you have here. If you want to install a plugin, you just go to Manage Update Sites, and you're going to see this window here where you can just check whatever plugin you want to add to your Fiji version. Okay, so just check and then apply and close. Then you go back to the window earlier, apply changes, and then restart Fiji. Now, the most basic thing that you should know before using Fiji is, of course, opening your image files. So you can always go to File, Open, and look for your directory of images, or you can just, have your directory open like this and just look for the file that you want and then drag and drop it on the main window. There. So what do you see when you open an image? At the top of the image, you have information besides, of course, your image title. You have information about the image resolution, the spatial resolution, pixel resolution. In this case, it's 512 by 512 pixels. The image type, this is 16-bit, and the amount of memory required by the image. All of this information is also shown via the metadata. So if you go to Image, Show Information, if your microscope saves the metadata as well, then you will find all the information in this window. You can also go to Image Properties, and you will find, that this is a single channel image. It has one slice, so it's basically a 2D image in one frame. It has the pixel width and the pixel height information in microns, which you can already see here. This would be the total based on 512 pixels. Okay. Now, if you want to open more than one image, all you need to do is, just click and hold down your shift key and just drag and drop. And then all of these images will be open. You can close all these images together by going to File, Close All. And as you can see, there are some commands here that have a shortcut. Usually they would have the control added to the shortcut, but you don't really have to worry about that if you go to Edit and then go to Options and then the miscellaneous command here. As long as you don't check require control key for shortcuts, then you won't have to press the control key every time you have to do a shortcut. Okay? So I'm just going to do the shortcut now, which is Shift W. Okay. Now you can also open a series of images. So you have here like a folder with several kinds of images. Okay, so when you open them, all you need to do is, drag that whole folder in. And it's going to ask, okay, what type of images do you have? You can just put in default, especially if they have the same file format. And it will tell you, okay, start from image 1 all the way to image 49 because there are 49 images. Step of 1 means that you want to open all those images. There's a scale there. So you open up your images in 100% scaling, or if they're quite large, you can scale it down a little bit. You can sort the names numerically, use a virtual stack, which is basically like a disk resident way of loading your files, especially if they are very large images. So you just need to use virtual stack, and then once you click OK, then you should be able to find an image there. You can open all of these files as separate images as well. Okay, just now it's very easy to just drag and drop an image into the menu bar if they are TIFF files or JPEGs. However, if you have a native file format that you want to open, you would need the bioformats importer, which is shipped with Fiji. So you don't have to worry about that. It's there. So let's say I have this image here, which is a CZI file, which is acquired from a Zeiss microscope. You can drag and drop it. Okay, then you're going to see this bioformats import options window, where you would be able to, choose an option on how you're going to view your files. And notice that if you hover your mouse over like a particular parameter here, you would see the information about it. So a description of what you will be seeing under this information window. And you can split channels if you need to. And the color mode, you can view them in different ways. Okay, I'm just gonna put default here. And once you click on OK, you're gonna have your image open. Okay, so this image here, if you look at the information, it says 1 in 4 images. You see there a slider with a C, meaning this is a 4-channel image. Okay, so you have a slider here where, once you move it, you're gonna look at a different channel, and 3rd channel and 4th channel. Okay, so the question would be, okay, how do I maybe look at my image merged? what you would need to do is just, you can just go to the image and color and find this channels tool, or just go Shift C, okay? So once you have the channels tool, you'll be able to view your image in grayscale mode or color mode. This is in grayscale, but it's just colorized in green right now. So you can look at your channels one at a time here. And if you go to color, because this image was acquired with a lookup table, channel 4 is displayed this way, channel 3 in blue, this is channel 2 supposedly in green, and channel 1 in red. You can view this image as a composite. So the composite is a multi-channel merge of all your images. So just click on composite and you will see all the images, individual images. You can just view, just some of the channels that way. Okay. You would also have some other ways of displaying your image. This would be via this composite max, which sometimes may affect how your image is displayed. It might look better or not. You have a composite min, which basically inverts the lookup table so that your background becomes lighter, but your colors remain the same. There's also the composite invert, which basically, might improve the way your image is displayed as well. Okay. Now, what do I mean by composite max, composite min, invert, composite? All of these information, you can just click on the help button there and you will see a description of what they really are. So what else can you do with your image? So since you are viewing a composite image, if you go to more, you can create an RGB image. Okay. So once you click on this, you have this RGB image here. And note, this is 4 channels. Okay. So, you can split it. So if you split this RGB image, this is what you're going to get. So this is what I mean when it comes to saving RGB image for analysis. You can see that the nuclei and this other channel are together in this blue channel, and then you have the green channel here and the red channel. So these are, this is not really good for quantifying. We can put all these channels together again by merging the channels. And you can just select any color that you want. Ignore the source LUTs if you want. Okay. And if you create a composite image, it will go back to being like 8-bit or whatever. If you don't check this, it will create your RGB image. There you go. All right. So now when you, of course, want to split the channels here, you can just go ahead and do that. And obviously they look really different from what you had earlier with the RGB image. The colors you can always change with this lookup table. So lookup table might be in your toolbar here, or if you can't find it, you can always go to image and then there's the lookup tables here. You can change the color of the image, so you can just go select a different LUT. So you can maybe just go like green hot, for instance, and it would make your image look brighter, but it actually doesn't change anything in terms of the pixel information of your image. Okay. So that would be the channels tool of your in the menu of Fiji. I'm just going to close all of these now. This time, this is an ND2 file taken from Nikon. So if I drag and drop this, you're still going to see the same window. Click OK. And you're going to see some options here. And the reason you see options here is because this image was acquired at 3 different positions of the sample. And it is like a time series with a tile scan as well. So you can select all these images to open, or, just check one of them and open them. So you just click on OK, and it should open your image. Okay. So this is a time-lapse image, although of course this is just a static image. If you go to image properties, you should see that there are 4 frames here in the image, which means that there are 4 time scales. And you have the pixel width and voxel depth. This is not a Z-stack, so the voxel depth, you don't have to worry about that. You can just leave it as 1. And then you can see also that there is a frame interval here. So the image was acquired every 83.6 seconds. Okay. Now there's another one that I'm going to show you, and this is having to deal with really large images. So this image here, which I'll open with bioformats. This is a pyramid image. So as you can see here, there are variable resolutions that are displayed here. So many of them. And if you select the very first one, or maybe even, up to series 5, perhaps, it will be very difficult for ImageJ to open them because these are really, really large files. Okay. So the best you can do is, open the image with the, slightly less resolution. So let's say this one here. I'm just going to select them and just make sure that the first series is not selected. And then you can just click on OK so that you can see your image here. Okay. So this is a very downscaled version of the actual image, which is like a whole slide image. It's a pathology slide created by a slide scanner. If you zoom in on the image, so there's this magnifying glass here, which you can use to zoom in on your image. As you zoom in, you cannot really tell where the cells are in this image because it's really downscaled. Okay. So how do you open the image in full resolution, and how would you analyze this image? My advice to you would be to use the software called Qath. So Qath, this one here. This is for 2-dimensional images and really large images. And you can just drag and drop your images as well on the window here. So let's just drag this. Okay. So it will ask you, okay, what kind of image is this? This is a bright field image taken with H&E staining. So I'll just select that and then I'll click on apply. Okay. Now, this is your full scale image. You can look under image information, the width and the height of the image, 122,000 pixels. That's such a large image. And when you zoom in on the image, you would be able to see the nuclei. Okay. So this is your way of, doing your analysis with a really like a whole slide image. Okay. But of course, Qath is not our lesson for today. we're gonna use Fiji. So let's go back to Fiji. Now, if you are tired of opening, like, let's say, several images in a proprietary format, you don't want to see that bioformats import window every time you open an image, there's a way for you to get around it, of course. So all you need to do is go to plugins and go to bioformats and go to this bioformats windowless importer, and you open an image once and that's it, right? Or you can just go to this plugins configuration. Okay, I'm just gonna go here. And under formats, you will see here all the image files that can be opened with bioformats. Just check by windowless. And once windowless is checked, you can go ahead and drag and drop your, well, CCI file in this case. So the next thing to do is to be able to use this sample images here. So you just go to File and Open Samples. Okay, so there are a bunch of images here that you can use to practice when you're playing with Fiji. We're just going to open this stack. This is a 5-dimensional stack. So when you see an image like this, you can see, okay, you've got C here, meaning there are 2 channels. You have Z, so this is a Z stack. And you've got this play tool. So this is basically like a time-lapse image. So this whole image here is called a hyperstack. Okay, so a hyperstack is not just a plain stack, but it is a hyperstack. You can reduce the dimensions in a hyperstack image. So you just need to go to Image, Hyperstack, and reduce the dimensionality. So for instance, you want to keep the channels and all the slices, but just look at, a particular slice. So whatever slice you are in right now. So just uncheck frames. You can keep the source image, so it's just there, and click on OK. So now we have this image with 2 dimensions, the channels and the Z stack, but you're looking at, this particular frame, the 4th frame of the hyperstack. Okay. So we're gonna just close that. So usually, like in the files that we previously opened, the pixel size and size calibration are already written into the image file during image acquisition. But not all image acquisition software would do this. So if you need to do size measurements, you need to manually enter the pixel values if you know them. So for instance, if you want to measure the length of this cell, for instance, just use one of the tools here, particularly the line tool. And because you can see that, the title image of the image just gives you the spatial resolution in pixels. Once I, draw a line across that cell, you can see in the status bar the length, and that would be 286.45, but that would be in pixels. So if you are asked what would be the measurement in, say, microns, what do? You have to know the scaling when you took your images. So usually the microscopes will provide you with that. Let's say I know the scaling for this. I would just go to the properties of the image. Okay, so you can see that it's just in pixels. And all I need to do is type in the pixel value that I know. So it's 0.12581, and this is in microns. So you can spell micron the full way or just type in okay? And so once you click on OK, as I said, voxel depth doesn't really matter here because this is a two-dimensional image. Just click OK and you will see that it's now spatially calibrated. So if you draw that line again and look at the status bar, your measurement of 35.64 would be in microns. Okay, so this is calibrating your images. If you know the pixel information of your images. Now, there are images that need to be acquired, so with like a ruler or like a reticule, just so that you know the pixel information. Let's just open a sample image here. That would be this leaf. Okay, so this is an image of a leaf with a ruler to provide the scaling of your image, right? So let's assume that this one here, one measurement would be in centimeters. So how do you scale your image? Obviously, it's in pixels right now. So let's zoom in on the ruler. Okay, then you would draw a line from, this to this here, meaning that would be about 1 centimeter. Oops, just that. Okay, let's say it's accurate enough. Okay, so the next thing to do is to go to Analyze, Set Scale. So the distance in pixels would be, the distance here. This is 58 microns, or not microns, but pixels, 58 pixels. Your known distance is 1 centimeter. Okay, so cm. Okay, and you can check global if you want. That way, if you have several images like this, once you click global, all your images will be scaled the same way. So just click OK. And you will notice now the scaling. You can look at that in properties as well. There. And notice that the name also has a G. That G represents that your global scaling is on. Okay. So let's zoom out of that. Let's say because global is on, if I go ahead and just draw a rectangle on just a leaf portion, I can duplicate this image so that I keep the whole image here, or you can also crop it if you want. So just click OK. So notice that the new image that is acquired will have the scaling, the same scaling as the original image. That's because global was on. Okay. Okay. So it looks like, okay, this image here has variable like intensities. Okay. Let's say you can't really see this, some of the details here because they're really dim. What you can do is go to Image, Adjust Brightness and Contrast. So you'll see this window here with sliders. You can see also a histogram of the pixels of the image recorded at particular intensity levels. This is obviously an 8-bit image, so you see only 255 as your maximum intensity. So you can change the brightness and contrast of this image so that you can display it, in a way like this. You can change the contrast as well. You can just use the auto button, although auto button would usually saturate your image, like a small percentage of the regions in your image would be a little bit saturated. So you can move this up a little bit and then create an RGB image from this. But since this is just a single channel image, you can just go to image and then go to overlay and flatten this image. Once you flatten it, you have that RGB image that is saved. And this is what you can use to present your image in like PowerPoint or something. Okay. But in terms of analysis, whatever you do not click on apply, because once you click on apply, that will give you this warning that the pixel values will change if you click on OK. So I'm just going to click on cancel. I'm going to show you the histogram of this image. Besides this, of course, you just need to go to Analyze Histogram. Okay. So you can see that, all right, there's a maximum pixel value already of 255 in this image. I'm going to put it to live mode so that whatever I do to the image, so I'm just going to click on reset here. What is changed is like how the grayscale values are displayed here, but you still have the same minimum and maximum values. Once I do this auto scaling and apply it, I'll just go ahead and click OK. This is what's going to happen to your histogram. So you're going to see a whole lot more of pixels that are saturated. So this is basically clipping your image because you have changed the values of your pixels already. Okay, so before analyzing your images, never do the apply here. Actually, to change how this is displayed. So besides changing the brightness and contrast, you can use a lookup table. So I'll open the histogram again, put it back to life. Okay, so I have a lookup table here that I installed, and this is JDM Grace, and I can display my image in one of these lookup tables. Basically, this is doing a non-linear adjustment, like applying a gamma correction to the image without changing the pixel values. So if I click on this is how your image would look like. Notice there's no change in your histogram. Okay, so if I change the lot to a different, but this is like a really good image to display. Like if I just change it to something else, it would look like that, and still nothing changes in your pixel values. Okay, so that's how you can, display your images. You can also display it as an inverted image. I think there is like this. So this is an inverted LUT kind of image. Okay, so different colors to represent, give you a better display of your information. Let's just open this. Okay. So going back to the histogram of the image, this is a 16-bit image, okay? So if I look at the histogram, you can see that there are more than 255 pixels, obviously. Intensity values, I should say. I'm just going to go to live. Okay. What if you want to change this 16-bit image to something that, can easily be applied to other plugins? Because there are plugins that won't work if you have 16-bit images. They only take 8-bit images. So you have to make sure first that changing the type of your image would allow you to be able to quantify your image accurately. So based on this histogram, you have a maximum value of 14,677. Okay. So if I duplicate this image, just so that I keep this original image here, okay, and open another histogram for this, put it to live. Okay. So how do I change my 16-bit image to an 8-bit image? You would need to go to Image, Type, and go to 8-bit. Okay, so let's say we do this. Note that your histogram has changed. And so, of course, it goes all the way to 255. But now you see that there is clipping in your image because you have saturated pixels already. So if you were to quantify this image, especially in terms of intensities, then you wouldn't be able to get really accurate information. So the key message here is that it is really easy to change the bit depth and the type of your image, but also very easy for things to go wrong, especially in terms of analysis. These errors can be really small, but they may also destroy your data. So if you know how to show your images and generate histograms, you will be able to check what is happening to your data every step of the way. Okay. And this is to make sure nothing is being lost in, the way, especially like here in terms of changing your bit depth from a higher bit depth to a lower bit depth. Another thing that you want to check is that if you go to Edit and Options, if you go to Conversions, you have to make sure that the scale when converting is checked. Otherwise, if you leave this unchecked, something else might be happening to your image. So let's say I take this out and click on OK. Okay, so I'm going to go back to this image here and duplicate it. Then I'm going to change this now to an 8-bit image. Okay, so this is what you're going to see. If you look at the histogram, you see that there's a lot of pixels here that are saturated now because you have, converted your image without the calibration. So make sure that's something else that you have to check when you do your any changes that you make to your images. Go to Options. Again, I'm gonna click on Conversions and Scale. Sometimes you're just gonna see this image as like all white, especially if everything is saturated. Okay. So just close all. Here. We're gonna open this image. Okay. So this image is clearly a Z stack, and it's a composite image as well. just going to, okay. Okay. So some people ask me, okay, I have a bunch of images. When I open them, they open as a stack of images. How do I present this image? Obviously, you only want to present this maybe like as a two-dimensional image. So what you can do is do a projection of the image in order to decrease the number of dimensions in the image. So there is the tool here. Go to Image Stacks. Go to Z Project. And you have the start slice from 1 to all the way to 90. And you can change this if you don't want to project everything. There are different ways of projecting your image. The most popular one, of course, is the maximum intensity projection. So if you just select that, you can just click on OK. And you have this to represent, all the slices that are packed or topped in, put on top of the other. And this is just obviously a two-dimensional image apart from, the two channels here. You can also choose a different way of projecting your image if the maximum projection doesn't work that well. So let's say a standard deviation. So you would see something like this. But obviously, because it's taking standard deviation, it's doing calculations. The image that is produced is now a 32-bit. It's a floating point image. So basically, this here 8-bit is an unsigned image format, while 32-bit is floating point, meaning your values here would be fractional. So there would be decimals or image values, whereas in an unsigned format, you would see your integers in whole values. So from 0 all the way to whatever bit depth you have. Okay. So besides projections, Z projections, you can also, of course, do a three-dimensional projection. So you go to Image, Stacks, there's this 3D project. Okay. And you can choose the projection method, finding the brightest points here and then applying that to all the image slices, nearest point, or get the mean value. You can change the axis of rotation. So I'm just gonna choose the y-axis. The slice spacing, which usually depend on, the properties of your image. And all of these, the total rotation, the increment of angle. So you can just click on OK. Okay, so if I click OK, you can see a new image stack here with a movie playing, a three-dimensional projection. But, if you look at this particular image at certain angles, you would see like, the lines here. Now, what does that mean? This means that the image, when acquired, had such a large Z. So in terms of image properties, for instance, this was taken with a voxel depth of 2 microns, which is pretty large when compared to the pixel width and height of the image. It's also possible that, this 2 microns here, with this 2 microns, when you're acquiring your Z stack, you actually miss information that would have been present if you took the image and with, a smaller pixel size. Okay. So how can you avoid this when you're doing a Z projection? You would have to do an interpolation. So you go back to ImageStacks and do the 3D project, and you want to check interpolate. That way, when you create your image, it would interpolate through all those, empty spaces so that your image would look smoother. So let's say this is at image 10, so I'm going to go back to 10 here. So if you compare, you have an image like this versus an image like this. Obviously, you would want to present, a movie, with this kind of projection rather than this, okay? What other ways can you show this image stack? So it's called a stack because you have obviously a set of two-dimensional slices that are placed on top of each other. So you can do what is called reslicing. Reslicing is repeated slicing. So you slice your image, in whatever angle you choose. So if you go image, stacks, and go to reslice, you can choose, okay? So the output spacing here is 2 microns. You can use 1 pixel spacing. If you want, you can change this or just put, the same pixel width and height. That way you get an isotropic image. You can start reslicing from the top of your image or from the left or bottom or the right of your image. I'm just going to do it on the top. Flip. So you can just choose any property here, but I'm just going to leave that as is. Once you click on OK, you're going to have this new image here where the Z here would represent now how you would view your image as if you were looking at that slice from the first slice towards the last slice. Okay, so obviously here you don't start until you reach this coordinate, right? So once you reach that, then you would start seeing your images here. So basically this is like what you see at the very top. And then as you go down towards your image, you would start seeing the rest of your image stack. And that would be reslicing. The other way would be to just do an orthogonal view. So the orthogonal view is, of course, obviously it's also reslicing, but you see the XZ view here and the YZ view on this side. So there, that's where your lines are. That's basically reslicing your image at that particular dimension. So that defined axis and dimension of your image. Okay. You can also just draw a line across your image and just go to image stacks and do like a radial reslice. That way this line would be rotating about the center if you select that. And you can choose whether the rotation is clockwise or counterclockwise. There'll be 1 degree per slice, or you can just change that as well and click on OK. And so you can see it here. So obviously because of the resolution, the Z resolution of the image, you would see this, right? Okay, so I'm gonna do a dynamic reslice on that. So a dynamic reslice would be click on OK, and then you can change this. So whenever you change the line that you're looking at, that also changes the reslice projection that you're seeing here on the left. All right. If you go to the plugins menu, there is the 3D viewer. So this is another way for you to view your Z stack in 3D. So it's like a reconstruction of the image. Usually you will be asked to display this as a volume, but you can always choose a different way to display your reconstruction. You can resample, especially if you have a large image file, but because this is like a really small image, you don't want to resample. This resampling means downscaling your image. So I'm just going to click on or type 1 here and click on OK. So you're going to see your image here. Okay. And you can zoom in with your mouse, the roll wheel of your mouse to zoom in and, just rotate your image if you like. If you need to change the brightness, you can go to this transfer function. Okay, choose the color that you want to adjust. And in this case, I think the first channel, you have this line here. You just need to move them. That's just changing the intensity. And you could see that this is changing the brightness of the pixels here. Of course, you can always reset that. Click on OK. You can also choose to show the coordinate systems, meaning, the X, Y, and Z, to show the bounding box, which is this one here. So that you can see that, okay, this is an image, showing you the Z, the depth, right? Of course, you can just choose something else. You don't need to show that. You can show the coordinate system. So you can see X, Y, Z there. Okay. But all of these, I do have a tutorial which delves more into detail about the use of the 3D viewer. It's just, this is just another way to present your images. There's also ImageJ, which is a plugin as well. If you don't remember exactly where it's found, as I said, you can always type it in. So ImageJ here. And so this is a plugin here from BIJ. So if you want to use this plugin, you have to have this in your manage sites. So you just need to click on run here. And you're going to see this window. Okay, so basically this is rendering your image. And you can render an 8-bit image, although it would be in one color. So if I click render, you'll have to select, of course, the stack that you are rendering. You can keep everything here as is. So ray trace, and no index here. And you can, change this for sign mode rendering. So if I just click render, you will see this image. So this is just a rendering of the first slice of your image. If you want to do the sign mode, it might take a while depending on how big your files are. So, you can change this sign increments so that there's less files. You can change the rotation axis. You can also change the scaling if you want. So just make a really small image here and rendered sign mode. So you would see that it's rendering in 3D mode. Of course, we lost a lot of the resolution because this has been downscaled a lot. So when I zoom in on it, you'd see that it's not doesn't look very good. But if you did this in full scale and, just render it, in every 10 slices, then it would look much better. But if you want to look at the colored, the composite image, you would have to make this image an RGB image. So since I still have my composite image here, so I'm just gonna close that. I'm going to create an RGB image here with all the slices here. So this is my RGB image, okay? So I'm just going to go back to volume J. And run it. Okay, so you can always render in full scale, as I said. And now, because we want to reconstruct this RGB image, you have to make sure that this is selected, okay? You don't have an index stack because we're working with this RGB image. But for the two colors here, or an RGB image, you want to go with this classifier. It's called ramp plus index. And just render a single slice, it would look like this, okay? So index stack can only be 8-bit, of course. So this is a single slice. So if you want to render the whole thing, you want to click on render sign mode. And so then you'll have to wait until it renders all the slices. So it's basically rotating your image. Normally there would be 36 because you have a 360 rotation with an increment of 10. And so now you can see, as you rotate your image, you have a rendered 3-dimensional image. Okay. Again, I have a tutorial on Volume J. So if you want more details on how to render your images using this plugin, you can tune into my tutorials. Okay, so I think we can go now to a different image. Let's say we open like a time-lapse image. I'm just going to open samples here and the tracks here. So this is a time-lapse image of like beads. These are fake tracks of beads moving over time. Okay. And if you go to image properties, you would see that there are 50 frames because it's a time-lapse image. Sometimes your image metadata records, the wrong acquisition parameters and puts 50 here in Z instead of in under T. So what you can do is, just go to image properties and just put 1 for Z slices and 50 for the time series. So you can just interchange them. So we're just going to move through this slice now. There is a way for you to present the fake tracks here.
Yeah, this is recorded.
As an image, like a depth by using depth coding. And this is, if you go to Hyperstacks, there's this temporal color code. So if you click on that, even though it's not a hyperstack, you can choose the LUT here for presenting your image. So I'm just gonna go with the default here of fire. I can create a time color scale bar. So if I just click on OK, Then you're going to see your time scale here and see that, as you go through the different time frames, the white here represents the last time frame, and then the lower, like the blues, the purples would be towards the beginning of the time frames. So you can present your images this way. Of course, this particular image has like quite a large amount of background. So there are ways to make your background look cleaner than what it is right now. And that would be going to process and subtracting the background. So in the subtract background here, it uses a rolling ball to to go across your image, and you can set the number of pixels. Usually the number of pixels would be like the size of the largest object that you see in your image. And of course, if it's smaller than that, you can keep this radius. There is a preview mode here. And so this is basically subtracting whatever background there was. If you select create background, this basically shows you that this is the background that will be subtracted from your image. Okay, and then you can, test a bunch of stuff like a sliding parabola. You can separate out the colors if you want. That way, when you look at your image, it would look something like this. It is still noisy, but that really depends on how your images were acquired. So once you click on OK, then you have your background subtracted. Okay. At this point, of course, once you close an image, it's always going to ask you whether you want to save that image or not. Okay. So if you intend to use this for a presentation, you can always save this image in a format, usually it would save by default as a TIFF image, but you can always go to File and Save As, and you can see the different formats in which you can save your images. You can also save your image as a movie, an AVI, if you need to do, the stack of images as a movie. All right. Okay. There's one more image that I have here. You see that there's the name of your image. Sometimes you can't really see what's next here in the image information. So what you can do is you can go to image stacks, and you can go to tools and remove the slice labels. If you do, then you would see all the information. So the resolution, pixel resolution, the image type, and the amount of memory required for this image. Obviously, you have the channels tool to help you look at your images separately. And as you can see, the green channel has like a really large amount of background. That's why when you display it, it looks like this. So what you can do is, of course, subtract your background. I'm going to duplicate this image right now. If you want to duplicate, the whole thing with all the colors, then you have to check duplicate hyperstack. Otherwise, if you have that unchecked, then you will just be duplicating, whatever color you are in right now. And that would be the blue color. So I'm just going to do this. Okay, so we're gonna work on this particular image. Go to more, and I'm just gonna split the channels. Okay. So whatever you do to your images, like especially if they're like separate images like that, you have to do it with all your images. So if I'm going to apply a background subtraction on one channel, I might as well do it on the rest of the channels. Okay. So I'm gonna choose process, subtract background, apply a rolling ball radius, preview that image. Okay. So you can always change the rolling ball radius if you need to. So let's say I do 100, so you would be able to see something like this. Okay. So let's keep 100. Just click on OK. Of course, what happens is the brightness of your image is affected. That's because the pixel information on the blue channel here also includes the pixels of your background. So we can do the same thing on the second channel. Preview that, click OK. And the third channel. And just click OK. Right? So with these images now, we can merge them. You can ignore the source lots if you don't want to have these colors, okay? But I can create a composite image as well. Keep the source images if you want to do analysis on them. Just click OK. And so you can see now the difference between an image with high background compared with an image where background is subtracted. Thank you for listening and for allowing me to present my perspective in using Fiji. I do hope that it was worth your time, and I would love to hear from you, hear your thoughts and how we can improve this presentation in the future. So feel free to email me your suggestions or comments.